Hello and welcome to another one of my videos on malware forensic analysis. In this series of videos we're going to be taking a look at this particular strain of virus here called Virut.ce. It's detailed in this Kaspersky Labs white paper as infecting machines and peaking at infecting machines during 2010. So it's not a particularly new virus to take a look at. However, it is detailed as being polymorphic, so it's quite interesting to take a look at those particular techniques. So a polymorphic virus will, the actual malicious part, the payload, will be encrypted in the infected file, and along with that, in that encrypted payload, we'll have what's called a stub. And the stub is in charge of, when the malicious file is executed, of executing that stub, unencrypting that payload, and injecting that unencrypted payload into a new process or an existing process, or just executing that in memory. So the interesting part comes during reinfection. So during reinfection, that polymorphic engine re-encrypts the malicious payload using a new key, and doesn't just attach the old stub with it. So it actually mutates that stub and puts that in the newly infected file. So if there's a antivirus signature that's looking for that exact pattern, it has less chance of being able to detect it in the new infection. So antivirus software vendors have to work a little bit harder at making a signature that will detect all strains of infection to do with this Virut.ce. So when it comes to actually testing this, I'm going to be using the lab that I detailed in a previous video. So I've had to do a few tweaks to the lab for this particular malware strain. So this malware sample, I've obtained two samples, one from virus share and one from offensive security. So this particular sample here is from offensive security. The malware sample has anti-virtualization and anti-debugging techniques when it first executes. So it knows when it's in a virtualized environment and it doesn't run certain bits, and it knows when a debugger is attached to it and it dies. So I've had to do a few tweaks to the lab, as in I've had to get rid of the virtual tools on here, and I've had to just do a few tweaks to some of the VMware hardware on here just to remove it so that there's no fingerprints of it. And it runs now. Originally, I thought I could cheat when I was wanting to unpack it. So this video is designed from the perspective of an organisation who've been infected with a piece of malware. All they want is the unencrypted payload to examine. They don't care about the obfuscation techniques and how intricate they are at hiding that payload. All they care about is dumping this out. So originally, I just thought attached this sample to OllyDebug, and so I know that most of these packers, they will allocate a certain amount of memory when they're unpacking, and then they'll unencrypt the malicious payload, and as they do so, they'll insert it into that memory. Most of them use a common operating system API call. In this case, a lot of the ones I've seen use virtual lock. So I thought that I could just put a breakpoint in so that if any blocks of memory had been allocated, that Ollie stopped, let me step through each of the following instructions after that point, so I could see what was being populated in that memory, and if it looked like a portable executable, that I could just use Ollie to dump that out and then start analysing it using other tools. Unfortunately, that didn't work. It looks like that malware looks for some sort of it has some sort of counter cycle counters, so it kind of dies. So I'd have to edit this payload for it to run in there. I have to work a little bit harder to do so. The technique itself with Ollie, though, is a really good one to start with. So it's documented quite well in this blog here, Paul's laboratory blog, and it's fairly easy to follow. If you prefer videos, There's some YouTube videos that you can follow on. I think there's a channel called Malware Analysis for Hedgehogs, which is a really good channel. It's really breaks these sort of techniques down quite well. What we're going to do in this video is we're just going to see if we can execute this malware in this dirty lab environment. Just see if we can detect any sort of fingerprints and understand a little bit more about what it's what to look for when we know that we've fully unpacked it. And then in some later videos we'll have a look at running those techniques and unpacking them. A good thing to do initially, I think, is just to have a quick look at the payload, at the sample in a few tools. So what I like to do, it's just personal choice, is I like to quickly load it into either and just take a quick look at what it's saying. So it does a few checks initially. It's saying here that it's already detected that it might be packed. So we'll load that in anyway. It's good to know it might be packed. Straight away we've got we've got functions here with a lot of jumps through code and a lot of cyclic jumps as well. So they're all looping around. So I mean, to spend and to invest time in doing some static analysis on this is going to be pointless to an organization if all they care about is the payload at the end. Some of these, that's not particularly big. That's just a little star. Okay, so look, say we want to map this particular, this particular subtask out manually, and where all these jumps are going, and work out what all of these XORs are doing, how it's unencrypting the payload or unpacking. It's going to be a huge amount of time to go through this particular graph. One thing I do like to do initially is just quickly have a look at what strings are detected. Okay, so this is detecting nearly no strings at all. It's got basic libraries that it's detecting are being called, and they're in the RSRC section of the file. It screams like it's packed. It screams like it's malware to me. So there's not much that we can do here. This would be a good screen to go back to when we believe we have a sample that we've extracted that could possibly match the fingerprints that we've detected. So this would be a good view to probably come back to. I run any sort of hex editor will do, but you could, if you load it into a hex editor, you're more than likely going to see a few bits of unencrypted or some sort of plain text indicators as to what's being used underneath the hood. Okay, yeah, straight away there's indicators in there. So let's make that a bit wider so we can have a look. So it's the standard. I'm a portable executable file. I'm seeing UPX wrote a lot in here in plain text, which is quite interesting. So UPX is a packer. So this might be a candidate for something we want to have a look at later. Again here, it looks like that could potentially be a version number with this, saying it's UPX. Going down the file a bit more, if these are anything to do with variable names or directories, then they're all obfuscated because there's no English jumping out at me. There's a few potential bits of plain text in there, but again, it probably isn't. It's probably just by chance. A lot of repeated stuff in here. Who knows? And then all of this just looks like it's compressed or encrypted. But looking at the top there, I would most probably start with UPX and see what unpacking it using version 2 of it does. So in a later video we'll take a look at that. So I think we're at the point where we will execute this malware now. Again, I just want to reiterate, in the previous video I say, if you're going to execute malware, make sure you've got enough segregation between your VMs or your lab and anything that you care about. So I know that these are Windows only viruses that I'm about to run. I have enough segregation between these virtual machines and my host box, just in case. My host box is a Mac. You can quite easily run Linux. But either way, if you have a different operating system to what you know that this is looking for, you've got less chance of it kind of breaking out into your development machine. But you know, those caveats are all in the previous video anyway. So let's run this malware and see what it does. Oh, just before we do, in my lab I have a Linux machine, and on that machine I have inetsim running, and it allows me to just on this client box to run use unpack DNS to point at that box. So I know it's 192.168.77.201. So if I start that server and give it any access it needs. So when I browse the internet now, it's going to make a DNS request to my Linux box. The Linux box is going to say, that service you're after called modern.ie, yep, that's me. And it will service back, you know, whatever it's connecting via. So if it's connecting via HTTP, it will send a request back in you know, a web format. If it's IRC, it will send back an IRC request saying server fake mode. So if you're running a piece of malware and it's expecting, you know, a service to be running at the other end, and you don't want it to call out to the internet, then you know, running something like this is probably going to help you out a little bit. So let's run this malware, see what it does. Okay, so the malware is running, it's showing up as purple in Process Explorer, which probably means it doesn't know what kind of a program it is, probably because it's packed. So so that's interesting. Straight away we've got a couple of hits on here for some sites. You know, this one here looks quite interesting. You know, it's got IRC in the name, which kind of screams out to me that maybe it's trying to contact a command and control server, so it's waiting for instructions. It's not finished executing yet, so it's probably still waiting for some kind of command to come through. Again, this one here, this, you know, I bet if you check these on any known malicious sites, you probably find that these are command and control servers. So we've got thus far UPX to have a look at. If we do get it unpacked, we can have a look in something like strings, like we did in IDA, for these particular fingerprints here, and we can, or we could have a look straight in the code, see if we can try and find those. If we do see these, then we're probably looking at the malicious payload itself. One final thing we might want to do is have a look at how it re-infects. So that might be quite interesting. So if we take a default Windows program, let's take the command prompt, because that might be one that it looks for to infect. Because, you know, if I was going to look to infect something, every time someone opened the command prompt, I'd want to infect that. So let's have a quick look and see if it does actually infect this file. Okay, so that is the standard sort of fingerprint of command.exe. Let's run command.exe. Interesting, it might have already infected it when I copied it over. Okay, so that might not be the best of tests. What we can do is if we go into we actually go and have a look at the original fingerprint for that. So if we do another MD5 on that, yeah, you see, so it looks like you don't even have to execute it. Just copying it somewhere will infect it. Let's double check this behavior just in case. So I've got test program, and I'm wondering if it's going to at least let me extract it before it infects it. Okay, so let's have a look here. I think it's probably already infected it, but we'll have a quick look. Okay, so it's at least executed it. Yeah, it looked like that it actually infected it as soon as it copied it onto the file system. Okay, so that's interesting as well. So it does have the ability, still has the ability to infect new files. Let's just double check that it does do that. Let's go back to Windows and System32. And we'll do another MD5 on the command prompt. Okay, so that's 98. Let's go and actually execute that, just to make doubly sure that executing it also infects it. So that's 98. Okay, let's run that. Okay, so it's on copying it. Oh, of course it won't be able to infect it in here because it's in the System32 folder. Okay, well at least I know the operating system is a little bit safer. Okay, but we know that it infects files. Okay, so let's quadruple check. Because I've not run process monitor yet. See if we can bait it into it. No, you couldn't let it bait it into that, unfortunately. Well, to be fair, it probably infected it already. Yeah, probably infected it already. Before we end this video, let's just be doubly sure what this is doing. Okay, so we've wound this machine back to before it was infected. I'm pretty sure that if I copy the command prompt onto the desktop, that it will infect it. Oops. But I just want to make doubly sure before we start basing the next few videos off of this particular activity. So we want that. Yeah, so B98. We run that malware. Malware is running. Execute that file. Fingerprint has changed. Yeah, so it definitely infects files either due to executing it, or it will just have a look for any executable file that's sitting on in the same directory or around the file system. To be fair, it's probably running through my file system now trying to encrypt everything. So that's as far as I want to go in this video. We found out UPX, we found a couple of URLs that it goes out to try and infect, so that's going to be pretty interesting. The next video we will take a look at seeing if we can unpack this payload and start peeling back the onions. Thanks for watching. If you've got any comments, then please place them below. If you like this video or you like the series of it, then please give us a like or subscribe. Thanks for watching.